Hello, today I am going to discuss about how to derive volumetric flow rate based on the frequency signal generated. As we know, for all types of velocity-based flow transmitter or flow meter, its flow sensor will pick out the pulses inside the piping where the water was flowing. These pulses will generate the frequency signal, and this frequency signal will be fed back to the flow transmitter. Let's say one day we encounter some issue with the flow transmitter and we need to perform troubleshooting. The most important thing is before we do any troubleshooting, we have to understand the basic concept of velocity-based flow transmitter. So we have to know how to derive the flow rate reading based on the frequency signal. Before we go into that, let me show you the picture of one of the flow sensor. This is the turbine flow meter. This is a turbine flow sensor. You can see the turbine is turning when the water is flow through the turbine sensor flow cell. This is a sensor will pick up the pulses and then generate the frequency signal, and this signal will be fed back to the flow transmitter. And then this is the vortex flow meter where there is an obstacle here. This obstacle will generate the vortices, something like a pulses, and this will be picked up by the flow sensor in the form of frequency signal. Alright, so now how do we derive the flow rate reading from the frequency? Okay, let me show you the whiteboard. Okay, maybe I use a red color. As we know, volumetric flow rate is equal to volume per time. Of course, it's also equal to area time velocity. Today, we'll concentrate on this formula, right? Okay, since volumetric flow rate is equal to volume over time, it can be written in another way, volume time time. Okay, this is 1. And then volume per time can be rewritten in such a way we can put in pounds and pounds here. As we know, when we cancel pounds, it become 1 over time and volume over 1, right? So K factor formula is pounds over volume. It can be written as PUL, pounds per volume. And then 1 over K is volume per pounds. Alright, so this volume per pounds is equal to 1 over K. So Q is equal to 1 over K time, and the pounds per time is equal to frequency, or you can written as F. Why? Because frequency is equal to 1 over period, which is equal to pounds over time. So this is frequency. So if you want to inject the frequency signal by using the process calibrator or signal generator into the flow transmitter sensor terminal, we had to understand this formula. And so the frequency can be written as K factor time Q. Alright. Okay, depending on what unit that you use. This volumetric flow rate reading can be liter per minute, okay, can be liter per second, or gallon per minute, or cubic meter per hour, and so on. Let's say in this case we use liter per minute. As we know, frequency unit should be in 1 over second instead of 1 over minute. So if the flow rate that we use is a liter per minute, we need to convert this minute to second to match this second here, which is a unit for frequency. So this liter per minute is equal to liter per 60 second. Why? Because 1 minute equal to 60 second. So Q unit is liter per 60 second. So this formula can be written as K times Q divided by 60. Okay? Or K times Q per 60. Based on the given frequency signal that you inject, you can get the flow rate. So if let's say you want to understand easily, you can rewritten the formula like that. Q is equal to 60 times frequency, okay, divided by K. If let's say I inject frequency 50 Hz, you will get the corresponding flow rate. If you inject the frequency of 100 Hz, you will get another flow rate. Okay, so this is how we perform simulation of the flow transmitter by injecting the frequency signal. Let me show you another manual. This is the manual that I take from GF CNET. This is an example of the flow sensor terminal point. Okay, you can see sensor in and sensor V plus. So you can use a frequency signal generator or any signal generator to inject the frequency to these two termination point. So it will give you the corresponding volumetric flow rate based on the formula given just now. So that's it. Thank you.